Hello and welcome. In this video, I'm going to show you how to download and use the chemical reactivity worksheet from the AICHE website. The first step is to download the CRW, and for that, I'm going to Google AICHE CRW and simply click the first link. My computer works. There we are. This has some useful information, so it's a free software program freely available. You need to find the download and install link, which looks like it's over there. Yep, click there. And obviously you want to download either Windows or Mac, whichever one you have. Note that you will have to input your information. So I'm not sure if it checks to see whether or not you're an AICHE member or not, but they will email you the link. So you will not find the direct download link on this website. You have to put in your email. Preferably use your UFL email, and it will send you instructions to download. Now then, once it is downloaded, you can install it and run it. And I'm going to pull it up now. Okay, here we are on the home page. This is what it looks like. So I will click OK. I'm sure there's some other information in getting started, but this is the interface. It kind of looks a little old school. Kind of complicated, but like most softwares, once you know where to look, it's really kind of intuitive. One weird thing that you have to do is you do have to click new mixture and you have to name your mixture. So I'm going to say, I'm going to call this VJ's lab mixture. And let's see, we need to start by adding some chemicals to it. So I can add as many chemicals as I like. Let's start. Up here is where you will search for chemical names. So let's start with simply searching for water. And if you click enter, so there's also different search modes here. You can do kind of a fuzzy search or a word starts with, and more things will pop up. If you're looking for something specific, I think it's better to use exact. Once you find the one that you want, so water, there's only one, but there could be multiple here that come up in the search. You can either double click it to add it to your mixture, or you can click this add to mixture button. Here, there's some information just about the chemical itself. So they got a general description of water. There's some reactive groups for water. There's really not much there. Reactivity alerts would be any specific hazards that are intrinsic to that chemical alone, not necessarily anything compatibility wise. This is what we're using the sheet for, but this would be the individual reactivity hazards, some synonyms, and the NFPA diamond. So let's add some more things. Let's add something that I know would be probably compatible would be acetone. So let's just simply see if we can search ACE and maybe word starts with ACE. Let's see if it comes up. Aha, far too many things have come up. So I think I need to be a little bit more specific with my search. So let's try acetone. And it's still too. Here we are. Okay, so I'll double click it to add it. And once again, I can see the description of acetone. I can see any reactive groups. So acetone is indeed a ketone. I have a flammability alert here, some synonyms there, NFPA diamond. Let's add some other things. Let's try adding octane. And yeah, I was going to go back to exact search, but this is going to be okay. Double click that. Let's add something that I know is probably not reactive with octane. So because octane is highly flammable, oxidizers are not going to be compatible, I can guess. So yeah, sure. Let's try chlorine dioxide. So it says oxidizer there. So I'm adding this for illustration purposes. I know that it's probably going to be incompatible with the octane. Let's add one more. Let's add something really nasty. Sodium azide. Yes. Let's see this one. Oh, I clicked it twice. Sodium azide I know is explosive, and it's particularly nasty. I'm not sure why the NFPA diamond is not coming up. Maybe it's too much of a niche. Let's do one more. Let's do another nasty one. Hydrogen cyanide. Certainly you would not have these things just hanging around your lab. I certainly would hope. If there's multiple too, I would use your best judgment and pick the one that is closest to the situation that you have. Some of them are not really clear about, like, I don't know what absorbed is or what absorbed would really mean, or absorbed onto what. Let's try that one. Okay, now we have 6 different chemicals. When we are ready to look at the chemical compatibility, so we've got a mixture of things, we can simply click the compatibility chart icon up here. And this one took us a while to generate. Hopefully I'm still screen sharing because a pop-up window came up. Yeah, I think I'm sharing. So we have a matrix similar to the one that is in the book. So again, we have the chemicals listed here, and then interactions are listed on this axis. So this worksheet does not consider chemicals reacting with themselves. So that's why there's gray squares. It also doesn't consider duplicates. So that's why the upper right triangle is all blocked off in 0. So let's go and look at a couple of these. So it's also color coded nicely. So water, we hypothesized that acetone was going to be fine. So we have a green Y there signifying yes. Also, water and octane turn out to be compatible, which again makes sense. You don't want water and hydrocarbons really mixing if you are using the hydrocarbon as a fuel. But in terms of safety, there's no specific hazards that we have there. Down here, we have some legends. So red is definitely incompatible. And then there's also some cautions here. So we can look at these a little bit more closely. And then also we have a self-reactive legend here. So hydrogen cyanide is indeed self-reactive. That's the only one that is shown as reacting with itself, which is helpful. So if we click on any interaction, I like how it highlights it there. But the green Y's should all be the same. So no known hazardous reactions. Let's click on a yellow C. So we have between hydrogen cyanide and acetone, there is an exothermic reaction or polymerization reaction. And then on any of the ends, we should be able to click on them and it'll show us exactly what the issues are, specifically between these 2 interactions. So this is how you would use this worksheet. Oh, one more thing I wanted to show you. If I go back to before, this is also helpful. I'm back in my lab mixture. I can search for a reactive group itself. So let's click on, let's say we had an aldehyde, but we didn't quite know what aldehyde it is. We don't know what this R group is, but we do know that the chemical is an aldehyde. So you can look at it based on reactive groups and not just chemicals themselves. So see how the reactive group has been generated here. Then I can go and generate my new compatibility chart, and you see that aldehydes has been added here. So once again, the more chemicals you add, the more complicated the chart becomes, but you can add as many as you like, and you can analyze as many interactions as you like. So that will conclude this short video. Hope you enjoyed watching.